Just think about it. I'm sure you could find a nice Irish girl.
Oh my gosh, KJ's husband, I cannot imagine that.
In the EEP class, there was people like our age, they have like 4 or 5 kids.
Yep.
Remember? The South African?
Yep. Yeah.
Where's that?
Before they were students, they were fathers 3, 4 kids.
Yeah.
Same ages.
Oh my gosh.
Different countries, different cultures, you know.
Yeah.
All right, next chapter now.
Could you do one question?
Can I wait till the tutorial next week? Just try to remember it, okay? Yeah.
It wasn't from the homework actually. It was from the last classes.
That's fine. Yeah, that's fine. Wherever it's from. Okay. All right. So domain and range. So the one way we can think about a function is by taking numbers, usually numbers, not always numbers, from one set and giving us numbers in another set. So if you were to look at this, what function do you think this is? What I'm trying to draw. What's this function doing to my number? So for example, this function will take 1 and give 1. This is a squaring function, isn't it? So I just want to teach you some vocabulary first. The numbers you can use in the function. So this is called, what do you need? These allowed values for x is called the does anyone actually know the name for the values you can use?
Function.
No.
Values.
No.
Components. No.
We're getting closer.
First letter. Domain.
Yes. Domain. So that's what you call the values of x you can use.
X is the column.
X is what goes in.
No, I can't read it.
Domain.
It's-
Can you fix that, Tekken? Maybe if you push the highlighter back. No. This won't change the size, I don't think.
This is black. Yeah, that's fine.
Yeah, now we're talking. Well, nearly perfect. Yeah. You watch Flash?
Yes.
Do you like the ending?
Yes.
Yeah.
In the morning class, can you what Louis called you? Boy?
Boyu.
Boyo.
Yes.
Boy, what was it?
Boyo.
She said, ask any other teacher.
What's that?
Are you sure she got to Boyo? Like
Yeah,
B-O-Y-O?
Yes.
And
Is-
one more, one of the word, TV or something.
Divil.
Yes.
Oh my gosh.
Not devil, devil.
Divil, yes. Boyo is what people from the countryside call like other people. You know, like it's like Irish version of dude.
Boy.
Oh.
Yeah.
She calls dude.
Yeah, it's not dude here, it's boyo. That's the Irish version, right? And divil is like you're telling someone you caused so much trouble. You're a troublemaker. Wait, what were you doing, KJ?
He didn't do the homework.
Ah, yeah.
I did.
No, you came to the board and you were solving on the board. You're just supposed to write it.
By buttons.
Yes.
Stuff like.
Yes. Now, no prizes for guessing what the values you get back are called.
Range.
This is called the range, yeah. Exactly right. And these are the values.
You can use.
Yes, it's like these are the values of y, if you want to think about it like that. Alright. So this vocabulary is important. We'll have a look at some examples straight away. yes, and one final thing actually for vocabulary. We have a special word. Oops, sorry. We have a special word when the range equals the real numbers. That is, when the function can make any number, we call it onto. Yes. Onto.
When the range can make.
When the range equals the real numbers, that is, when all values can be made from your function. Like, I'll give you an example. Is x squared onto? And the answer is no, because x squared can only make positive numbers. Is sine x onto? No, because sine x can only make numbers from -1 to 1. Is e power x onto?
No.
No, it can only make positive numbers. Is 1 over x onto?
Yes. No.
No,
No.
because 1 over x can make every number except 0. You can't find an x that makes 1 over x 0.
So is there any
Only
code
positive
that we
numbers.
put in?
Just not onto.
Oh, yes.
Now, what is onto? So x cubed is onto,
Mm-hmm.
Oh yeah.
because you can make any number from x cubed. Log x is onto. Huh? X cubed can make any number. Yes? Pick any number. Like if you want to make an 8, then you just do 2 cubed. So you can make an 8. If you want to make a -8, then you do -2 cubed. You can make any number.
5.
7.
Well, then you'll have to, if you use the cube root of 7, whatever number that is, 1.8 or whatever, and cube it, you get 7. Now it doesn't work for x squared, because if you want to make -1, then you have to use the square root of -1 to square it, but that doesn't make any sense because you can't calculate this here. So anyways, onto just means you can make every number is possible.
So is there any other?
There are other types which we'll get to throughout the chapter. But for today, we're talking about onto. Alright. Can we do some examples now?
Yes.
Domain and range, okay. So for this question, I want to know what is the domain of this function. Hey, Karar, focus. So I want to know what's the domain of this function. So that means I want to know what values of x am I allowed to use. Anybody know?
2.
I can certainly use the number 2 for x. True. Could I use the number 2.5? Yes. So maybe you can give me more general answer. What values of x can I use?
0 to 3.
Could I not use 4? Could I not make x is 4 here?
0 to 9.
Dude, what are you doing? I can use any number for x here. Is there any value of x which I can't use that's forbidden?
1 over
Minus?
minus. No.
Dude. Boyo. You can put any number for x in here, can't you?
Yes.
Like, is there anything forbidden that you can't use for x?
0?
Sine,
No.
Sine 40.
No, don't complicate your life, okay? Think about the numbers from -infinity to infinity, including 0. Is there any number you cannot use in this function?
No.
No.
To make it positive?
No. Just, is there some number you're not allowed to use that would make a maths error on your calculator?
There's
No.
no number.
Of course not. So, you can say here that the domain is equal to all real numbers. You're allowed to use any real number here. Okay?
Oh my gosh.
Still weird.
No, not really. I'll do another example. Okay? What about this function? Gx equals 3x squared plus 5x plus 3. What's the domain here?
All real numbers.
All real numbers. Okay, what about this one now? the domain here? All real numbers. Now let's go on to ones where this is not the case. So let's say I had something like hx equals 1 over 8x minus 16. Now the domain here is not all the real numbers. There's a value for x which is forbidden.
0.
No. 8.
Still waiting for the right answer.
8.
Still waiting for the right answer. 2.
Oh, sorry, 2.
Dang. Right. So you had the right idea. You cannot have this to be 0. So you want x to not be 2. So you say that the domain is all the real numbers except 2.
What do you do that?
This means all the real numbers except 2. Just a slash. Okay?
Can we write D instead of domain?
Yes. Okay. Now, I'll give you a minute to think about this one. Don't just say the answer.
X squared, what?
Minus 39x plus 374. You might need your calculator, which I have.
What?
No, I got it. Yeah, you do need your calculator. Yeah, so using my calculator actually tells me that this has factors.
Yes, 14, I think, or 13.
No, 22 and 7.
Are
Yeah, I'm sure. Are you sure?
you? Yes, 22.
So here, now that I've rewritten it, you can kind of see more clearly what the domain is. What's the domain?
20 and 17.
No?
22
No.
and
No?
no, sorry.
Don't even think about saying 0.
Plus
Wait,
22?
we have to think about this.
No, you don't have to think about it. The domain is all real numbers except for 17 and 22.
That's what we said.
I'll say.
No, it wasn't. You
That's
didn't
what
quite
we
say
said.
that.
That's what we said.
Alright, fine. Now, we'll do two more, we'll do a couple more like this. So, f here, fx equals e power 13x plus 16. What is the domain here? Domain?
Okay. Is that 16 plus 16?
In fact, it doesn't matter, but yes, plus 16.
What's the domain? 0, nothing. Real number. No.
3 point.
It doesn't.
E.
Not real numbers.
What did you say?
Not real numbers.
So, no domain. You can't use any number for x here.
No, you
This is
can't.
impossible to
Except
calculate.
E. Except E.
Except.
Yes.
Except.
You can use any number here. Look. You can use any number in this. Why would you not use any number? Why would any number be forbidden? Can you multiply 13 by any number?
Yes.
Yeah.
Can you add 16 to any number?
Yeah.
Can you do e to the power of any number?
Yes.
Yes.
Why not?
Well, we have to do it because you don't know it.
No.
If everybody was giving me the right answer, then we wouldn't have to do it.
No, I'm just saying that why. No, I was just saying to ourselves.
Why what?
Why are we making confusing? No? It's just.
Oh, yeah. You're asking yourself, why is this suddenly confusing? I could do this last week. Right. Now this one here, I'll give you a minute to try it yourself.
Be careful.
Yes.
What are the factors?
What's
Plus
factors?
18.
Give us
Yeah.
the factors.
Okay. The factors are x minus 9, x minus 2.
Okay, all real numbers except 9 and 2.
That is wrong.
No.
All real numbers.
That is also wrong.
Just a minute.
You cannot use any minus numbers.
Correct. So you haven't included that in your answer. So
You can use 0 to infinity. And positive side, right?
2.19 and 0.6.
what is allowed for log?
Everything
And
above 0.
positive.
Correct. So all you're trying to do, guys, is solve this. What did I say the roots were?
9 or 2.
Yeah.
X minus 9,
Minus.
x minus 2. So here, if I want it to be positive, x must be less than minus 2, or what? Look, you want this piece and you want this piece. X must be greater than 9. So the domain is all the numbers from minus infinity to minus 2, or all the numbers from 9 to infinity. You can use anything here and anything here, because the quadratic will be positive, and the quadratic must be positive if it's going into log. Can I use, I wrote a minus there, I should have written a plus. Can I use 2 or 9? Why did I not include 2 or 9? Why did I not include the 2 and the 9 here?
If we use.
Because they'll get 0.
Yeah, if I use 2, sorry, that, again, why am I writing minus? If I use 2 or 9, it would make the quadratic 0, which is not allowed. Yeah?
If we use any minus numbers, so it won't like.
X could be minus, because you just care about the quadratic being positive, not the x.
Minus 3.
Yeah, you're confused now. Why is it that you can use a minus x number? Is it?
I'm just checking the
Yeah.
formula. So it's.
Does my story check out?
Yeah.
Okay. You got that?
Confused.
All right. One more
No,
of this.
last thing.
Okay. Just here?
Yeah.
Okay. Try this one now. If you think you're so smart. Boyos. Maybe I'll start calling you boyos. HX.
Now you're a city boy.
City boy. I am a city boy, actually. You know who's a country boy, don't you?
You?
No.
You live in the country?
No, Dennis.
Oh.
Dennis is a country boy.
He lives here.
I know, but his family's from the country. And he goes back like every weekend.
Oh.
Dennis grew up on a farm. If you wanted fresh milk and eggs, just ask him.
I'll tell him.
Tell him, ask him, yeah.
Okay.
Alright, try this one, try
What's
this one.
that, minus 20?
Yeah, minus 20 x plus 100. Do you want the factors?
Use a calculator.
Yes, well some people don't have theirs. The factors are just one factor, 10, x minus 10. You know what? I'm going to change this a tiny bit. Tiny bit. I'm going to make this plus 106.
Oh.
So it's
The factors are
No factors.
Okay, this should be easier.
Think.
Yes. From 0 to
Okay, I'll do it now.
from 0 to
Ah.
infinity.
Yeah.
No.
It's like minus infinity to
Mhm.
minus 2, then 2 to infinity.
No. What you can do, this doesn't have any factors,
Yeah.
so you can complete the square. You get x minus 10 squared plus 6. Remember completing the square? So for this question, the domain is all real numbers. Why is it all real numbers? Well, because what's inside is always positive. There's no value of x that can make the inside negative.
Oh yeah. Square, because of the square.
Yes.
Mm.
This is something to remove. What's the rules or what's the like?
See, there isn't one. You have to maybe factorize, complete the square, draw a graph. I mean, it's not like there's a formula or a procedure.
We just have
It's really kind of testing your understanding of what you've learned so far. You know, because you could factorize, complete the square. You know, it's not. There's not a one thing to do.
we just have to figure any method that we can find which value is for gives us like 0.
Yeah, like you want to think about what process would I need to use to find the values I can or can't use.
To make it like 0.
Or well, or negative, depends on the situation.
If it's negative,
Like, oh, here, I don't need to do anything because it's always positive.
yeah.
But another way you could do this, see, this is only one way to do it. Another way you could do it is like this. You could say, okay, you want x squared minus 20x to plus 106 to be positive. Now, when you try to find the factors, you will fail.
Yeah.
And in fact, when you do the discriminant,
Yeah.
you'll find that the discriminant is negative, which means it has no roots. Which is really, really good, because if it has no roots, it means the graph is like this, or the graph is like this. This one here is the graph is always positive, and here the graph is always negative. If the graph is always positive, then that's perfect. You can use anything. If the graph is always negative, that's bad. It means you can use nothing, because you'll always get a negative value. Now, you can know which shape it is because of the x squared. So you know you're in this situation. So it's your job to prove that this is always positive. And the way you prove a quadratic is always positive is by completing the square, which we did in the completing the square lesson. So you see, there's not one thing. It's putting together everything you've learned from semester 1.
Continuous is always positive because of x squared.
But this was something we did in semester 1, that when you complete the square, you can see if it's always positive. A square number plus 6 is always positive.
No, I know
I know it's always positive because it has no roots, and it needs to have roots to be negative because that's the cross under.
Yeah, I know that.
So then what are you asking me?
Why is it always positive or not always negative?
If it has no roots. These are the only two situations where a quadratic has no roots.
Yes, the only two
Yeah.
situations you're supposed to choose one. Then you're not pointed at because it is x squared.
Oh, because x squared is a U shape and minus x squared is a hill shape.
Okay.
Did you know that? Was that the drawer? Or was it outside? No. Okay. Right. Can we go on to the next part, the range part? Yeah?
Yes.
Okay, so the range. Right, so this function here, what's its range and is it onto? So, first question, what's its range? What are the possible values you can get here for the function?
Possible values.
In other words, what type of answers could you get? Could you get any number as the answer?
Any positive number.
You can't get negative numbers?
No, you can actually.
Can you get every negative number?
No,
Yes.
Can you get every positive number?
Think so.
Yeah, in fact, it's a linear. The range here is all real numbers, which makes it, we call it onto. Now, how can you find the range? There's two methods. The first method is by the graph. What type of graph is a linear?
Straight line.
A straight line like this. Can you get every y value? And the answer is yes. Like, for example, if you want this y value, you would have to use this value for x. Joshua, not Joshua, sorry, KJ, pick a number. Pick any number.
7.
Right, so let's imagine 7 was here. If you want to make 7 as the answer, you would have to use this number as x. So in other words, you can get all the y values here. Compare that with the quadratic. Look at this quadratic. Imagine here is the point 2. Could you get any number for y? No. You can only get the numbers bigger or equal to 2. For example, if I said make a -1, there's no way you can get to -1. You could get to 2, you could get to 3, you could get to 4, but you can't get past below 2. So
Can you change the value of x in quadratic?
What do you mean?
For example, if you change the numbers, so it will go up and down, right or left somewhere.
No, but if I give you a quadratic
Like this.
like this,
It was the graph.
no. I give you the function and you could make the graph.
Okay.
So anyways, I'm just saying, in your mind, you know the picture of a linear graph. It's like this, and that includes all the y values.
Yeah.
So it's real here. There's no calculation. That's my point. I'll make it. But when it's a quadratic, when it's a quadratic, then it's a little bit more difficult. So let's have a look at a quadratic. What were you asking me?
I'm saying if we use any number for x, any number.
Yeah.
Like to figure
Oh
out.
yeah. You can use any number in the domain to see if the y exists. Yes, of course, yeah.
Still no, I was saying different thing.
Huh?
I was saying different thing.
Okay, what are you asking me?
In quadratic,
Yeah.
if we use any number for x,
Yeah.
then u will go up and down, right and left.
Yeah.
So change will.
But you can't make every number for y. Let me show you with this one. Yeah. So if you look here, I think I'll do this the graphical way. There's multiple ways. Like I can think of 3 ways to do this. The first is by the graph. Okay. So if you want to draw the graph,
Can you draw this graph on the graph? So
you want to see it beautifully done.
Yeah.
All right, as you wish.
So it will be accurate. So
Yes, that's fine. Yes, that's fine. You'll need to call it to me. All right. So what I'm going to do is draw a graph. Now, in the exam, they don't expect you to draw a neat graph. They just want you to draw some shape, and then you can find the points if you like, and use that to help you. Okay. So actually, you know what? First, I'll do it very roughly, so I can see here. I don't know what shape it will be. I'm going to imagine like this. Here is -2. I'm not even sure if it has roots. Well, it does have roots. Let's see. 2 minus 1, 3. So the roots here is 1 and it's just one root. Anyways, we'll draw it neatly. Nice.
The graph. You can use this calculator and give you an exam.
Hey, is this not recording?
How much? From where did you buy this? From where?
Oh,
From where?
why did this stop recording? Oh well, I suppose that's life.
Online.
Okay, what was the function? -2. Yeah. So if I graph this, now, do you know how to find the roots of this quadratic? Do you?
Yeah.
Yeah.
Make it.
Do you know how to find this minimum point here?
Yes.
Yeah. It's -4, isn't it? this range is all numbers bigger than or equal to minus 4. It's impossible to make y less than minus 4. The graph doesn't go down low enough. You cannot find a value of x that will make y less than this number. And another way to show this is by completing the square. What you could do here is you could take the 2 out, and this is equal to 2 bracket x minus 1 bracket squared. So that would be plus minus 2. And this is 2 bracket x minus 1 squared minus 4. What's the smallest number that could be?
Minus 1?
Yeah, because the first number has to be positive. So the smallest it could be is 0.
If we use 10 minus 1.
10 minus 1 is 9, 9 squared is 81. 81 by 2 is like 160. So this will be a huge number.
But you cannot use 1.
But I can use 1.
Why? X is 1, cannot be 0.
Yeah, so then you get minus 4. So this is the smallest number you can get for y.
So you can use 0 as well.
Yeah, the domain, you can use any real number. But the range is only the numbers bigger than minus 4.
Why?
Because if you look here, minus 4 is the smallest number you can get for y. Because you're saying y equals this minus 4. The smallest, what's the smallest this could be? 0. So for example, let me ask you this. What number do I pick for x to make this equal to minus 5? Well, here's minus 4, yes?
Okay.
So this would need to be minus 1. Because together minus 1 and minus 4 make minus 5.
That's 5.
What number for x do I pick to make this minus 1?
1.
Oh,
2, 4,
So what number do I pick to make x minus 1 squared equal to minus 1?
4.
I can't pick any number because a square is always positive. So how could I make it minus 1?
Oh,
Minus 1. So you can see that it's impossible to make minus 5. Minus 4 is the smallest number. It is the minimum.
But I can make it minus 3.
You could make it minus 3.
To make it
You could make it minus 2. If you want to make it minus 3, then you would need this to be you would need this to be 1, wouldn't it?
Yeah.
And if you want this to be 1 and this is a 2, you need this to be a half, which means you need this to be a quarter. So I think you would have to use 1.25. 1.25 squared, 1.25 minus 1 squared times 2, no, not that. No, Karar, you would have to use 1.7. So 1.7 minus 1 squared times 2. Yeah. So you wanted to make minus 3, for example, you would need to use x as 1.7.
If we use 2, then we'll get 2 minus 4.
If you use 2,
Yeah.
yeah, for x,
Yeah.
yeah, you got 2 minus 4, which is minus 2. Yeah,
So you said we cannot go lower.
yeah, you can't go lower than minus 3. Minus 2 is bigger than minus 3. Is it not? Yes. Okay, that's one way to do these problems.
Another way.
There is another way. So the other way you can do it, can I scroll down? So I'll do it with like a quadratic as an example, okay? So this way you might like because it has a procedure to it. Okay? Yeah.
By the way.
So the first thing you do is you let y equal fx. So you get y equals 2x squared minus 4x minus 2. And then step 2. Step 2 is you
replace y with x. I don't know. This one.
No. Listen time, please. Then you pretend y is constant. So pretend y is a number. So if y was a number, what would you do? Well, you would bring it to the other side to put it with the 2, wouldn't you?
Yes.
So you'd end up with 2x squared minus 4x minus 2 minus y equals 0. Yes? Is that okay so far? And then the last step, which is the key step, is you ask yourself, when is this solvable? So, when does a quadratic have solutions?
And just
When
when they have roots.
Yeah, and when will it have roots? How will you know if it has roots? Use what, yes?
Delta.
Discriminant, delta. So, when is this solvable? Answer, when discriminant is greater than or equal to 0. True? Yes, we are agreed? I'll show some energy. Yes, we are agreed. Yes, alright. So, we have here b squared minus 4ac must be bigger than or equal to 0. True?
Okay.
And remember, what did I say to do in step 2?
Pretend.
Pretend this y is a constant, so this is like a number. Alright.
Where's x?
Where's x where? Here?
No, the 16.
16. There's no x here.
Then
b
can-
squared. B squared. This is b.
Oh,
Did you have breakfast?
yeah,
Did you have lunch?
yeah.
Good.
I can pick any number for y?
No. Keep it as y. You're pretending it's a number.
Okay.
Right.
B square minus 4.
Yeah, come on, wakey. It's a long week, I know. Right, so here we have 16 minus 8 times minus 2 minus y. 16 plus 16 plus 8y, bigger than 0. Is that right?
Yeah.
32 plus 8y, bigger than 0. 8y bigger than minus 32. Y bigger than minus 8. No, so sorry. 4. I have one more example to do, doing it this way.
How frequent
So the range is
I
minus
have
4
one
now.
thing. I have one
How-
The range is everything bigger than or equal to minus 4.
Remember when you said if
How
you
frequent-
take-
Whoa. Slow down there. Let me just write the answer down. KJ first, Kara second.
How
On.
frequent does this question come out in the exam?
Frequent. Like, I would say 75% of exams would have a domain or range question in section A.
3 marks.
No, if it's something like this, it could be 4 or 5. You're not escaping it.
It's when you divide something and this will switch. Then
Yeah,
you-
but I'm dividing by positive 8, so it is not required to switch. Right. Can I do one more example? We'll do something a little bit simpler. Can I go down now?
Yeah.
Yeah? Okay. So let's say here this function gx equals 1 over 12x plus 12. Right. Question. What's the domain here? I'll give you 10 seconds.
And in real number.
The domain is minus 1.
Put your answers together.
All real numbers except minus 1.
The domain is all real numbers except minus 1. Okay? So that's the domain. Right, now let's get the range. So what's step 1 here? Make it equal to y. Step 2,
Pretend.
we play the pretend game. Y is constant. So if y was a number, let's say 4, what would you do next here? if you were trying to solve this.
We multiply that 12 by
Right, that's right. You bring it up, wouldn't you? So you would get 12yx plus 12y equals 1.
Yeah.
Right? Now, if this, remember, if y was a number and you were trying to solve this, you know, what would you do? Well, you would do more steps to it. So I'll just bring the 1 to the left to make it equal to 0, because I kind of like having it equal to 0, like it's a quadratic almost. 12yx plus 12y minus 1 equals 0. Now, you all have imaginations, so you really need to use your imagination here. We're thinking this is like a number, okay, and this is like a number. So what type of equation is this?
Linear.
It's linear. Now we do the last step.
Oh, yeah.
Yes, we're happy.
Yeah, this is linear.
We're happy like students on a Friday afternoon, huh?
Yes.
Yes. So, last question is, when is this solvable? In other words, when will a linear have an answer? Or, if you prefer, when does it not have an answer?
When it's 0.
When what 0?
The x,
No,
y,
no. What shape is a linear?
line.
Line.
Yeah.
So when will this not have a root? When will it not be equal to 0? When it's like this.
Y is equal to 0.
No, think before you open your mouth. Because you know this answer.
When
This line will not cross the axis and therefore will not have a solution if it's horizontal.
x is equals to
I will slap you. You don't want the slope to be 0, because if the slope is 0, it will not cross the x-axis.
Yeah.
So if you wanted to have a solution, you need the slope to not be 0.
So 12x must not be 0.
No, that's not the slope. What's the slope here? The slope is, what's the slope of this line? This is 12y
Y.
is the
I
slope.
said 12y.
Okay, fine. This is the slope. 12y. Yes? So, for this to be solvable, what do you need?
Must be
Not 0. So that means y must not be 0. So therefore, the range, what do you think the range is? All real numbers,
Our real numbers
except 0.
except 0.
When you were saying it's 0, 0 range, said no.
No, when you're saying it's 0, or 0 range, or x is 0, or y is 0, this is not it. I wanted to hear when the slope is 0.
Excuse me, before because 0 doesn't cross the axis or
Yeah.
y axis?
Yeah. Mx plus c.
Okay,
If you want this to be equal to 0,
okay,
you need the slope to not be parallel to the x-axis.
yeah, sure.
That happens when m equals 0. So for it to cross the axis and have a solution, you just require that the slope is not 0. Which means that the 12y is not 0.
What if it's on the axis? It would.
True if it's on the axis, but I know that this one's not on the axis because it has a c here.
Yeah, then
Okay.
I'm asking if it's.
Ah, yes. It's kind of weird because then it has infinite solutions because it's lying on the axis. And I don't think I give you any ones that complicated. But,
Okay, what if it's a minus? It's going to cross.
yeah, if it's it doesn't matter if it's a plus or minus. If it's plus or if it's minus, it doesn't matter.
Shouldn't be 0.
Just not 0.
Yeah.
Yes, I see that.
Homework.
Yeah. Now, because this is new and because it's difficult and because it's the weekend,
We have to do all.
Yes.
I want the column down the side.
What?
This column here.
We've not done
And-
the previous assignments. Finished.
Well, thank goodness it's
Physics.
Saturday tomorrow.
Physics lab reports.
Set the alarm.
Chemistry.
Set the alarm for 9 o'clock and get working. No. Look, do some maths for a few hours, put on an episode of Arrow, then do some more physics for a few hours, then you can watch a Supergirl, and then do chemistry for a few hours.
This is something that changed.
What class have you got next?
Nothing.
So you have 2 hours now as well. So quit your complaining and get working.
Still, I've heard like the new math teacher doesn't give